Okay, I think it's about 2 o'clock. Should we start, or do we want to wait? Let's start. All right. This is basically a presentation on PrintK, the most basic thing in the kernel. Yeah, maybe not the very most basic thing, but very, very low. And the reason to do this is basically, in spite of this kernel being more than 20 years old, people still create bugs. And poor people like me have to take a look at stuff like this. And in case not all of you are kernel hackers, I suspect, in case you've not seen this before, you know some process did something wrong, general protection fault. You don't even have to understand what it does. What you should usually look at is the address of the faulting process. And in this case, it's target complete command plus some hex number. And you should look at the kernel version, and maybe you have some extra version behind it. With that, you should be able to find the sources of the kernel, or even the compiled image. You can disassemble it through GDB or object dump or whichever you prefer. You will find the code at this address, and you will notice that it is a listdel. Take your kernel source, look at listdel, and you notice that it will take 2 pointers, rdx and rcx, which are the list head, and it will remove the list head from the list, and it will add poison values to those 2 pointers. Those poison values happen to be dead 200 something and dead 100 something. So essentially, the poison ensures that if you try to do listdel again afterwards, you will crash, like we just did. So at this point, you know that someone did listdel twice on some object. You figure out which object it is. You, at this point, know either you have a race condition or you have a ref counting bug somewhere. In this particular case, we had both. So there's 2 patches that I still have to send out. And you're done, pretty much. So that is kernel hacking made easy. The real question is, you want to get this information from the kernel. If you don't have this information and all you know is your computer crashed, there's not a lot you can do. So this is basically a session about my quest to actually get this information. And the most ancient way, I believe, at least for Linux, the most ancient way to get to this information was to use the VGA console. And effectively, that means you have about 80 by 25 characters to use. Quite often, you have call traces that are more than 25 functions deep, so a lot of the interesting information has scrolled by. Then your system has crashed. You probably want to reboot and restart whatever work you were actually doing. But at the same time, you want to take a look at the crash and actually understand enough of it to debug it. So effectively, that means that we usually have a 60-second timer, and now you have 60 seconds to grab your digital camera and collect the crash. And yeah, usually not a lot of happiness follows afterwards. And more urgently, well, nowadays of X not so much anymore, but some people actually want to use the console to do real work, which is what they bought the computer for. And they don't want to stare at some kernel messages all the time. So the solution to that is slightly older than I am, which is you define a few levels of importance, and really, really important messages when basically your printer is about to burn. You print whenever you can, and if it is some debug message, then you make it very unimportant, and the user can decide how much spam he wants on the console and what sort of stuff you filter out. And you can have permanent flame wars about which exact log level one particular PrintK should have, and it sort of works most of the time. This one actually had to debug. If anyone wants to help me with that, I would be pleased, but I believe the bug has been fixed by other means in the meantime. I just gave up on this. Basically, these lines that we see, stack, call trace, and all of that, are important enough that it happened to go past the console log level. And the really interesting stuff, the call trace itself, the stack itself, are gone because they were in a different priority and they were not printed.
Usually the code has a square bracket where the actual fault happened.
Yes.
But it's not on there, is it?
The microphone is on the phone. When you move that to the table, it could be better.
Or turn it off.
Or turn it on. Yeah. Make Rosted use it.
Yeah. Or just repeat my question.
What did you say?
I said.
There. Now it's on. Okay. Yeah, this is probably the squeal. Yeah, the what's it called? The code usually, because I just actually debugged something today using the code, and usually you have a little less than sign, greater than sign around the location of the code that crashed, unless it scrolled off your window there. Usually, and you can use that if you have an idea where the code is to disassemble and find, oh, here's where the line that it actually crashed on.
If you don't have an alternative, that is a perfectly acceptable way to reduce your sanity even more. My solution was that I didn't ever want to debug this again, and I wrote a patch to make sure I always get all the information. I actually have I'm in the nice situation that I can control the code base, which you don't always have with customers. So anyway, the second console I believe we have for Linux is basically the serial console. You have a serial cable, which effectively gives you about 9,600 baud. It is, again, a real console. People actually use this to log in to do real work. So again, you have this whole log level thing on it. In principle, you can go up to 100K abouts. In reality, when you actually do it, you see lots and lots of missing characters, and your output is garbled, and it depends on the quality of your cables, and you have all sorts of headache, and you can spend weeks of engineering time, which you should not spend on serial console. Oh, and in some project, when we moved from 9,600 baud to 115K, the boot time of the system was cut in half. So the best use for serial console is disable. One good thing about serial console is you can actually have a daemon on the other end of the serial cable, and you can simply dump it all to a file, and you can read this file at some later point in time. You don't have the 60-second timer to find your camera. So there's one good thing about it. And Syslog is great. It captures everything. It can take almost any data rate. The only problem is that when your system has crashed, Syslog is usually not in the state to actually tell you about it, and that means you're back to the system has crashed, something happened, please fix. Uh, 9600 baud limit is a soft limit. You can go faster, but if you go faster, sooner or later you will get those strange characters. Basically, your data will get corrupted. If you want to be able to read the output, then your limit is effectively somewhere around 9,600 baud, maybe a bit higher if you have better cables.
I was about to say, you need to buy it right here. You need to buy better serial console, because I use that. I've never had issues. Except the only time is when I do a full dump of the ftrace buffer and it's doing megabytes of data through there. Every so often I get a glitch, but
okay.
99% of the time I don't have an issue with that.
I was not in charge of procurement. I wash my hands in innocence. Okay, now we come to the real topic of the talk. NetConsole, I believe the initial version was written by Ingo almost 10 years back. The idea of NetConsole is to have something really crappy that may or may not work. You send every message out by UDP. If someone is listening to it, great. If someone is not listening to it, great. And to everyone's great amazement, it actually works. There's two problems. One is the format, which is what you get is what you get. And if you don't get it, you don't get it. I will get back to that later. And the second problem is that you don't have any sort of feedback loop. With TCP, if your network is slow and you're dumping lots of data, then your buffer will fill up and you will not write data any faster than your network can handle. With UDP, if your interface can send it out, you will send it out, and if the receiving end is overloaded, it was overloaded, so be it. So that may or may not be a problem. Usually when it is a problem, you have a bug, and usually you care when you have a bug, so I guess a common theme here is that every single solution we have sucks in different ways. So the best approach I have found is to use all of them, and hopefully one of them actually works in this case. One nasty thing I found with NetConsole is you have your usual way, or our usual way to setting it up is to pass a boot parameter. So the kernel boots with NetConsole equals some character string. This character string includes the IP address you are giving yourselves. If you then do ifconfig and you want a different IP address for the server, or actually a different server is using the IP address you pass to NetConsole at boot, it will continue to use that IP address, which can lead to confusion. You can have two servers who claim to send NetConsole from the same IP, and it will end up in the same log file. I'm not sure if it continues to send stuff if I've configured down an interface. I think then it stops because the hardware is disabled. But pretty much whatever you do as an administrator gets ignored by NetConsole, and it keeps sending as if nothing had happened. And the alternative is, I think in the last 2 or 3 years, there was a dynamic interface to NetConsole. This is actually a bit of code that I may actually have written it myself or something. We have some setup script that is ghastly horrible, but this is part of it. Essentially, you can create a directory in sysfs. You can fill in a bunch of parameters, which is your local IP address, remote IP address, and so on. And you say, I want this as another logging target from now on. And that is great. That allows you to dynamically change the IP effectively. It is a bit awkward to use, which is fine. The two big problems are, number one, you will lose all the kernel output until you actually do this. So you actually want to pass in a boot parameter so you get the early boot messages. And number two, you cannot remove the console you created when you booted the system through this way. You can remove all the dynamic interface, the dynamic net consoles you added, but not the original boot console. If someone wants to write a patch, this is a great project, I think, to fix. But then again, it works good enough for me that I don't care enough, and I have real bugs to fix. Someone then actually has to sit on the other end and receive all the crap you're sending. And this is from documentation network netconsole. And it says that you can send the stuff to syslog, which I tried, and it actually does work, sort of. I found the RFC for Syslog. This is RFC 5000 something, so Syslog is at least 20, 30 years older than the RFC is. And this is part of... I should not stand too far to the front. This is part of the ABNF definition of Syslog, and basically you have lots and lots of formatting. And if you remember, netconsole sends WYSIWYG. If you happen to send data that matches what Syslog expects, great. If you happen to send a random byte string, great. And what Syslog afterwards does with your random byte string is anyone's guess. And the reality is that usually when you send a single line, it comes out great. When you send some more single lines, it comes out great. And the moment you send, well, a lot of data, like a crash dump, you get garbled results, and it is effectively unusable. So that is actually a very simple patch to send. Remove this line from the documentation. The alternative, actually two alternatives, there's netcat and SO netcat, but they are both effectively the same, I believe. Netcat is basically the same as cat, except you can read or write to or from a socket. And that is perfectly fine so long as you are a single developer in your own flat and you have one test machine and one server that controls it. And I've used it for several years and I was perfectly happy. If you happen to dump it all to a file and you want to archive the files and you use logrotate, then it doesn't work so well because when logrotate wants to compress the file, well, logrotate expects that you actually open a new file descriptor, which netcat doesn't do, so you have to kill netcat and restart it again, and that means you have a tiny window where you lose data, but it's UDP anyway, so you have all sorts of tiny windows where you might lose data. So it is a bit crumpy, but it is not too bad. The problem is pretty much when you actually have something you might call a test lab, and the number of machines is at least 1 or 2 magnitudes bigger than this. We had a script that basically created a namespace, and depending on the host name of the machine, we would write to a different port on the capture server. And then we added more machines that had different host names, and we had to carve out a new namespace, and that was a huge headache. And basically, I was desperately looking for something that would be better, which was written 5 years before I started looking. Lucky me. Joel Becker, I believe, worked for Oracle at the time, and somewhere at Oracle you can find the tar-gz ball. Maybe I can dig it up. It was, CanCD is basically a single process that captures data from many IPs, and it simply creates one file per IP. And the way it was set up by, or it was written by Joel, was basically as if a crash happens, dump it to a file. If it is not a crash, then don't bother. And then you end up with a weird directory hierarchy and lots of crash dumps in it. I hacked it up and probably broke more stuff than I fixed in the process. And I basically wanted it to behave more or less like our horrible netcat script that we had before. And I also care a lot about the non-crash information. Basically, all the stuff that the kernel spews out is quite often very interesting. And usually it's the 5 or 10 seconds before a crash that you want to read in order to understand the crash itself. And sometimes you just want to grab across all your output to see if something has happened in the last year. It is not often, but sometimes you do care, and when you care, it is quite important. So my version, I added, we used to have even uglier hack. Every half hour we would echo date into the log files, which was horrible. So then you had to figure out what time something actually happened. I added timestamps to every line. Con all data is not actually part of CanCD, but that is a tiny patch I did to netconsole. Basically, if you have a console that has con all data set as the console flags, you will ignore all the log levels, and whatever stupid stuff gets printed, you will receive that stupid stuff. And I said that for netconsole because you remember the hack stream that I was not willing to debug before. This was my fix for that. Over netconsole, I will now always get every line, provided the network is actually good enough to receive it. When I set it up, it was a rare moment when it actually consumed more than 10% of one CPU, so I didn't care all that much about performance. And I wrote it really stupid, so every time it receives something, it opens a file, it writes to this file, it closes the file. If you can spot an obvious optimization.
Now, why do you do that instead of like reacting to sync hop like most programs?
What? The question was, why do I not react to SIG-hub and then reopen the files? And the answer to that is, this was less work, and I didn't care at the time, and the performance was good enough. By now we have more machines and we're logging more stuff, and maybe I should start caring and do this, but I was just being lazy, and there were 2 managers behind me telling me to actually fix some bugs instead of working on the infrastructure to fix bugs.
You could set up log rotate to send your process a sig hub.
Yes, I could. But then I would have to write the code to actually process the sig hub, and I would have to deal with the lifetime of the file descriptors. This way, at any given point, I have 0 or 1 file descriptors open. 0 when nothing happens, and 1 when I receive a packet. I open a file descriptor, write to it, close it. The code is that simple.
Well, keep it open and just write to it when you receive it.
But you have hundreds of machines that are writing to you, and you have 1 file descriptor for every one of those machines. You don't want all your log files to be 1.
Oh, yeah.
So it is a bit more complicated, and it is just work. But since this is my time, I'm a lazy bastard, and feel free to send me patches. The code is on kernel.org, I believe, and I take patches. I may be somewhat slow to react, but if anyone wants to lighten my load, I am more than happy. This is not the company I work for. This is, I believe, Backblaze they are called. The philosophy I have to log files is very simple. I do not ever delete any of them. So if you ever have people asking you why you keep these log files that are more than a year old, your answer to that should be one of these things, I believe, can store 180 terabytes raw, and it costs around 10K. And if the question ever comes up, just buy one of these and be done with it. Do not delete log files. If you want to buy something else, that's fine with me as well, but really disk is cheap, and the cost of not having the log file you care about, even if it is 1 year, no, especially if it is 1 year old, is so much greater than this puppy. So just don't do it. And yes, we have had cases of bugs that were absolutely new. No one had ever seen them before, unless we checked. So, by the way, this is the reason why you probably shouldn't buy this exact puppy. They are so cheap for Backblaze because they buy a lot of them, and in real terms, you might be cheaper off if you buy from Supermicro or some white box salesman of your choice. I just found this picture pretty. Kgrep. Now that I have this one machine to do them all that gets all my kernel output, I started out having some grep that I basically grabbed for call trace, and whenever there was a call trace, it was something I wanted to look at. Then some jokers started using syscontrol C, which, if you don't know it, crashes the system. And at first I sent around some mail saying, please do not crash my systems. It creates work for me. I have to look at it and decide that this is a false positive, and I don't care. Actually, we have a test that deliberately crashes our system in order to test how we behave on crash. It is perfectly valid to have this test. It makes a ton of sense, so I was getting sick and tired of looking at all of this stuff, and I created a script that filters out the false positives. It has thrown some random stuff like if the watchdog reboots the system, I have a small patch that 2 seconds before the watchdog actually hits, I send out a message on PrintK, and I do sync and stuff like that. And I want to watch for these watchdog messages to see a system rebooted because of a watchdog, and I know who to kick about that and stuff like that. So I will not post the script. It is horrible, and it only applies to my specific company, but it is easy enough to write for yourself whatever you need. And it is useful. And no, let's not go into politics. Let's go into sad stories. Recently, I had a simple one-liner fix that was supposed to fix something. I compiled it, I stuffed it into our test rig, and I found a bug in our test rig, which basically meant that I was testing not the code I had written, but some other random code. It didn't behave the way I wanted it to behave. I stuffed in some debugging stuff. I stuffed in the print hex dump bytes, which basically meant all commands going to our array I would print out. It was a very small number of commands that went in because I did them myself. And after a while, I found the bug. I actually tested the kernel I wanted to test. I stuffed it in, went home, was happy. The next day, our networking was down, completely down. People couldn't log into any boxes and all sorts of stuff. The entire network had melted down. It turned out this stuff got into our automatic testing system, and now lots of commands were printed by hexdump, and we had lots and lots of hexdump going over PrintK, going over netconsole, going to this one server to rule them all. I believe the biggest log file was about 36 gigabytes for 1 hour. The partition ran over, and basically because the capture server is a VM that was taken offline. So now no one was listening to this IP anymore, but there was still traffic going to this IP, and the switch thought, why don't I just broadcast it to everyone? Not a very happy result. I believe I mentioned before that there's no feedback loop whatsoever in netconsole. Someone might want to add it. That someone might even be me. Something stupid, just a tiny subset of what TCP does would be enough. Have a small budget, you write your budget. If the server responds, you write more. If the server does not respond, you don't exceed your budget, and that budget better be small. And this would have never happened. Or some amount of rate limiting and whatever. But what you learn from this story is be careful with netconsole. It can bring down your network. It has. Another thing to learn from this last war story is if you can avoid it, do not use a VM to capture netconsole. One thing we found was, before this whole shebang happened, we started having packet loss. On some crash dumps, usually the first crash message was clean, but in some cases, because we were waiting for some completion signal, and in that case, we didn't care about the process that was hung. We cared about the process that was supposed to do the completion, so I ended up dumping every single process's backtrace in the system. There's a lot of processes in the system. There's a lot of stuff going over netconsole, and all of that stuff after 10 or 20 backtraces ended up being corrupted. It was corrupted because there was packet loss, so why was there packet loss? That packet loss stopped when we actually reserved CPU for the VM. Use a white box, use hardware, if possible use 10 gig Ethernet, scale the hardware way ahead of what your test system is supposed to be, and you will be off happier. Block console. Block console is basically, I wish I had netconsole, but I can't. Usually it means you have some customer systems where you don't have control over the network, and you cannot just tell the customer, create a VM or use a dedicated machine or whatnot. Sometimes it is your test system is this shiny little notebook, and the network attached to it is sadly missing. So the idea was to simply dump everything on a USB stick. It is slightly more generic. You can use any block device, but I don't believe anyone is using anything else so far. Unlike CanCD, which I broke, this one was actually fixed by a bunch of guys from SUSE, I believe. And the assumption is that I have some piece of flash that is about as bad as flash gets. And flash can get really bad when you buy cheap. And essentially, I assume I can do sector writes. and I write in round-robin fashion. I never rewrite a sector unless I wrap around it completely. And if the system crashes or reboots or whatever, I try to find the end with some granularity. I call them tiles that are 1 megabyte in size. And they have a small header, and you can do binary search to find the correct header to continue and be done with it. So that, I believe binary search has to do 10 reads or so on boot. That ended up being fast enough. And that actually, like Net Console, I can demonstrate. This is a small VM I have set up. It's KVM, and it boots. And if you take a look at the config string, it has somewhere block console, a device that I pass in, which happens to be a USB stick. And if we simply open that up in a text editor, something weird happens. Okay, that is not. You can look for this header. The header is actually plain text ASCII, so you can read it. It is designed so you can open up in a text editor. You have this line, which is a random number in hex dump. In case you have more than one USB stick, the idea is to simply initialize the USB stick with some random number, and that way you can distinguish the various devices. The second number is a loop counter. Every time you actually wrap around, you increment the loop counter, which usually should happen about once in the lifetime of your device if you use a large USB stick and you don't log too much. If you log way too much, it can happen in a day or less. And the third one is the tile index. That actually explains why I didn't see anything in the start. And 2 simply means this is the third tile, actually. And if you look for the same header again, you see tile 3, tile 4, and now it drops around. And the beginning always looks fairly identical. Actually, this seems to be the current one. If I go to the VM, do I find this line? 116 switching to TSC. Yes, no, I don't find it. Oh, demo effect. Okay. But one thing you do see is all of this yellow is actually white space. And that is my solution to the how do you deal with logging comes in a granularity of some bytes, and your block device you can write in sectors. Essentially, I have a 1 second timer, and if the timer expires, then I just pad whatever I have with spaces, put a new line at the end, write it out, and that means you can open it in a text editor and it doesn't look completely awful. And at the same time, you treat these crappy block devices the easiest way you can. So for some reason this time it doesn't seem to be writing to it, which I don't want to debug. I seem to have a bad hand at demos. So essentially, you can plug it into your notebook. You can plug it into any machine. I am abusing the partition scanner to detect the devices. So if you put the small header in the first sector, then it will detect this as a partition table and abuse that code in order to use it as a console device further on. And the only way to remove a block console from the system is actually to have errors. I try to be as robust as possible against any sorts of crap. So you pull it out, you keep writing to it, and if you have accumulated 10 errors in a row, it will disconnect the device. I don't try to detect disconnects or anything. I just respond to errors. It is completely stupid, and it is luckily it is stupid enough that it tends to just work. Now this is even more stupid. The problem now is that you have this great USB stick in the device, and you actually want to take a look at the logs, especially after a crash, and you how do you access them? You don't have them under var log, and I have this really stupid script that does the binary search for the end of log, and then it does a DD that copies the last 16 megabytes off. The approach is 16 megabytes ought to be enough to capture the last crash, and from time to time it can happen that you actually have more than 16 megabytes between the stuff you copied and then you're missing something tough. Usually, almost always, lots and lots of those 16 megabytes will overlap with the last time you ran the script. If someone wants to improve on this, please, please do. I just don't have the time for it. But as crappy as it is, it happens to work, and we have fixed a number of bugs because of this, and it has actually turned out to be useful. Which pretty much brings me to the end. There's a number of alternatives. These ones I sort of kind of know about. The alternatives tend to be collect crash information only and don't do general logging. You can, over InfiniBand, you can probe into some other computer's main memory. And if that computer crashes, you can probe the PrintK buffer and pull that out. There is some ACPI crash dump that depends on your BIOS actually having the correct ACPI tables. And we all know how good BIOS is. And we tried that and failed. And depending on your system, if you have MTD, MTD is the flash subsystem of the Linux kernel, you may have a tiny partition on flash that you can one-time dump a crash dump into. It is not very versatile, but when it comes to debugging, you take anything you can get. And the classic one, you can kexec into a crash kernel, then you can even collect the entire crash dump, the entire system memory in a crash dump if your system design permits. The problem I've noticed is that main memory tends to grow faster than your root disk tends to. So sometimes it may simply not fit onto your root drive in order to collect that dump. And then even if you have it, depending on where your customer sits and how stringent they are, you actually have to get all of those gigabytes of data from your customer, which may be a bigger problem. And with that, I would like to thank this guy for bankrolling this whole stuff. And he really has an inspiring work environment. Questions? Where's the mic?
Just a comment, really. On Chrome OS, we use something called pstore console.
pstore, I believe, is the ACPI thing.
We don't use ACPI.
No, wait. pstore is generic, and the original backing end for it was, I believe, ACPI. What do you use?
So the pstore console you can configure through platform data. So we just, the way we do it, the BIOS reserves a chunk of memory, and then we pass that as platform data, like with a base and a size.
BIOS reserves a chunk of memory. Does that include it does not get clobbered on reboot?
Right.
Yeah.
Lucky you.
Yeah.
If you could teach the BIOS not to do all that stupid stuff, life would be so much better. Anyone else?
I actually have a comment about the kexec. Because working for Red Hat, we've actually had lots of customers where kexec kdump was actually crucial for us. But our customers usually have the machines that can handle kexec kdump pretty well. One other thing, one plug I want to put in that a lot of people don't know is that usually when you get a core dump, not only does the crash utility that we have, analyze it like GDB, it also has the ability to create a trace.dat file. So if you kicked off ftrace and ran it on your machine and the machine crashes, you can actually get the ftrace ring buffer all the way up to the point where it crashed. And it creates a trace command.
Who might be able to decode that?
No, it would actually create
yes.
Me.
Of course. Actually, there's two more for completeness. There's we used to do a thing that really a one-off back at IBM days, where the bootloader would compress all of memory and store it somewhere and then write it out. And the IBM mainframes also, well, if you're in a VM on some hypervisor, the hypervisor can do stuff for you and it can collect the crash dump. So there is more ways to do it.
Another plug for pstore. Pstore also has the ftrace, ftrace buffer as well.
Cool.
This can be super handy.
I was going to ask you about your kgrep. How much log compression do you do? You mentioned that if you have a huge file store, obviously you would just keep whatever and maybe you run gzip if you care. But in your example of the on-device block console, it might be interesting on further reboot, not during boot time, but sometime during the boot, to then go back and do maintenance on the partition you saved. What parts of the log do you find to be essential to your debugging efforts? If you could give some feedback.
Block console usually only has to have the crash itself and a few minutes before. Up to fairly recently to the crash itself, you have Syslog. And at some point, the last sync happened, and anything from that point on is not in Syslog. The crash itself is missing. So block console really is about capturing those dying moments when Syslog is no longer available. And because Syslog does everything else perfectly for us, it doesn't need to cover all of that. We still have Syslog. We don't want to replace it. We just want to get this tiny window where we have a blackout otherwise.
You don't want to replace it, like systemd?
Yes, I did live in Hamburg for 6 years of my life, I believe. That is, the one time I actually met him was not in Hamburg. No, actually, there are wild, wacky plans I have for PrintK that I would like to do after the disaster we had. One of them is I want to make rate limiting mandatory. Any kernel message gets rate limited by something. Either for this particular kernel message, you have some ridiculously high rate limit that if you exceed a ridiculously high rate limit, then you really want this thing to shut up. And a global rate limit. I mean, this is really just, you don't want gigabytes per hour of stuff over net console. And if you have a better solution, please.
No. Well, the rate limit thing, because we do ftrace dump on oops, where you can have, well, if you say gigabyte, we don't have gigabyte going out for this. Usually we use serial output, which usually when I hit like my ftrace dump on oops, it's like, okay, time to go drive down to the local coffee shop and stay there for a while, and just let the console spit out. That's what I'm saying. Some things I can't see, like I'd ever want the ftrace buffers being dumped out over the serial or over the console to be rate limited.
Agreed. I mean,
it's usually the important information is the stuff at the end.
The two tricks usually to have is you don't rate limit on a small granularity. Instead of allowing, I believe the default is 10 messages per 10 seconds, you allow 10,000 messages per 10,000 seconds. And that means if you have one huge dump and then nothing going on, you still get your 10,000 messages or whatever your numbers happen to be. And the other one is you set your rate limit ridiculously high so that you only catch the really disastrous stuff and not when things are more or less as they should be. That and if I had feedback on net console, then maybe I wouldn't do the rate limiting at all. It really is a hack to prevent disaster. So if anyone wants to beat me, did I mention that I take patches? Okay, if there are no more questions, let's wrap up.